Air conditioning system. AC system is to provide thermal comfort inside the cabin and to maintain good cabin air quality through adequate ventilation. AC operation. Refrigerant is used to absorb the heat inside cabin and to release heat to the outside air. India government has mandated AC cabins including chassis and cowls for all trucks from 8 June 2025. AC variants in Ashok Leyland vehicles is as shown. Ashok Leyland is providing AC in all truck models from Partner Super to Avtar. AC system consists of compressor, condenser, thermal expansion valve or TXV, evaporator, pressure switch and control panel. The compressor is usually reciprocating type driven by the engine using a drive belt with an electromagnetic clutch being used to engage and disengage the drive to the compressor. Electromagnetic clutch will be triggered above the cabin set temperature as well as defined refrigerant pressure. To provide lubrication, a specific amount of recommended compressor oil is added to the refrigerant. The compressor compresses the refrigerant, thereby increasing the pressure temperature of the gas coming into the compressor from evaporator. This high pressure, high temperature gas is forced to condenser through the discharge port. The condenser operates using the same principles as a radiator and is placed ahead of CAC, radiator fan supports in heat transfer. Compressed refrigerant flow inside the core tubes from top to bottom. The forced air passes through the condenser externally and high-pressure refrigerant gas gets converted to high-pressure liquid state. Condensed refrigerant then enters into integrated receiver dryer IRD unit, which is the cylindrical tube that is integrated to the condenser. IRD captures moisture and dirt from the refrigerant and keeps the system in good condition. IRD also dries the refrigerant, as the moisture in the system has a bad effect on the compressor oil and the operation of the components. It also filters polluting particles. The liquid refrigerant flows to the expansion valve where the high pressure of the refrigerant forces it through a small orifice or hole. This has the effect of injecting the refrigerant from the orifice as liquid. Expansion allows the pressure to reduce, which also reduces the temperature. This causes refrigerant to again change the state from a warm and high pressure liquid into a low temperature, low pressure liquid. The expansion valve also adjusts the quantity or flow of refrigerant passing to the evaporator. Too little or too much refrigerant results in too little or too much heat being removed from the cabin area. The low-pressure liquid refrigerant now flows to the evaporator coil, which is located inside the cabin below the dashboard. The evaporator consists of numerous fins that are exposed to the air in the cabin area. The heat from the air in the cabin area is able to transfer to the fins. As the hot air in the cabin flows over the fins of the evaporator with the help of blower motor, it is absorbed into the refrigerant, thereby cooling the cabin. At the same time, when the refrigerant absorbs this heat, it vaporizes and changes back to a gas. This superheated gaseous refrigerant then flows from the evaporator and back to the compressor where the whole process starts again. There is a component fitted to our air conditioning system, which is the pressure switch that is used as a simple safety device. It monitors both high pressure and low pressure conditions. It ensures the AC system operates safely by cutting off the compressor if the pressure is too high or too low. Hose and pipe are used for interconnection between the various components of AC system, the compressor, condenser and cooling unit as a closed circuit. Thank you.